Hello everyone, my name is Franco Pucci. I am the technical consultant for the STS Association, and I have been involved in the prepayment industry for over 25 years. Welcome to the STS training video series where we will explore all aspects of STS and the STS standard. I hope you find these videos useful. In this video, we will deal with section 6.3 of the IEC 62055-41 edition 3 test tokens, and of course the reference source is that same document. If you have a look at 6.3.8 in the document, there is a table that contains all the control field values for the test tokens. You have essentially a number of bits representing a test number. With all bits set to 1, it is test number 0, and test number 0 specifies do tests 2 to 5, plus optionally any other test that you want to include in that suite of tests. Test 2 is mandatory, support the display and or reader devices if it's implemented. There are some tests on the right marked optional. That means you don't need to do them. But any test that's marked mandatory must be done, whether it's in test 0 or whether it's in the individual tokens. Those need to be covered. So depending on the bit that you set, it'll do that particular test. So it goes up to bit 18, and you'll see there's a couple more mandatory tests there, like display the EA value, display the number of key change tokens supported, and display the supply group code value. Now on that one, test number 16, it's mandatory for 3 or 4 key change token meters. For the 2 key change token meters, this is not mandatory because the key change token set for a 2 key change token meter does not carry with it the supply group code information of the new supply group, and in fact it will be reported back as 0. Display the key expiry number and display the DRN values. This is one of the changes that was made between STS edition 2 and STS edition 3. We added a few of these mandatory fields for the test tokens. Bits number 19 to 28 or 36 are all reserved. Normally, each test token has only 1 bit set in the control value. When more than 1 bit is set, the behavior must be agreed between the manufacturer and the customer as to how the meter will actually do these tests if you select multiple bits. It could do them in a particular sequence, or it could do them in whatever sequence is specified by the utility. These tokens are not encrypted and may be hard-coded into the token generator. The security module cannot generate these tokens because they are not encrypted, so the security module doesn't know what to do with them. So they could actually be hard-coded in, either into the token server or the point of sale. There is no token identifier in the token either, so it can be reused multiple times. So technicians often carry some of these test tokens printed on a piece of paper, and they refer to them when they get to a meter. All mandatory tokens must be supported by the POS type E for engineering tokens. And there are different tokens for 2-digit and 4-digit manufacturer codes. The meter may support both a 2 and 4-digit manufacturer code token. So it is an option to either accept the 2 or the 4 or both in a meter. If you have a look at some test token samples, with a control field of all Fs, all 36 bits set for a 2-digit manufacturer code, or all 24 bits set for a 4-digit manufacturer code, those are the 2 tokens. Those never change. So you could even memorize those, and you could use them to do test 0 on any STS compliant meter. Test number 1 means only one of the bits is set, and there are the tokens represented for a 2-digit manufacturer code meter and a 4-digit manufacturer code meter. And similarly for test number 16, there are the 2 tokens. Okay, so the token definitions, you can look at clause 6.2, and then for class 1, the initiate meter test, if you have a look, it's a class 1 token, all of them. The subclass is 0, and that is the bit position control of the test display number for 2-digit manufacturer codes. In this case, you use all 36 bits, and the manufacturer code portion of the token is set to a 0. On subclass 1, that is the same thing but for 4-digit manufacturer codes, and in this case you only use 28 bits. And in the manufacturer code, which is 16 bits, you set it to all zeros. Subclasses 2 to 5 are reserved by the STS Association and cannot be used. And then subclasses 6 to 10 are proprietary tokens for 4-digit manufacturer code meters. And the manufacturer code there can be 0100 to 9999 because those are the range for 4-digit manufacturer codes. And then subclasses 11 to 15 are proprietary for 2-digit manufacturer codes and also set to a 0 if not used. And the manufacturer codes in that instance are 00 to 99. Now, in the proprietary space, you obviously need to be a little bit careful because if you elect to use these subclasses 6 to 10 or 11 to 15, the manufacturer may elect to do other non-specified tests using these control field values. But then the manufacturer code must be included in the token to avoid collision with other manufacturers' tokens that use the same control field values. So you don't want the meter behaving erratically because it's received somebody else's test token in the proprietary space. Now, these proprietary tokens cannot be specified since we don't know what they are and they cannot be tested during certification testing. But you're allowed to use them as proprietary tokens. This brings us to the end of this part of the video series. I hope you found this video useful and hope you will join us again for the rest of the series. Goodbye and see you again soon.